Today, we start a new topic in Module 4, the last topic in Module 4, Quicksort, Part H. We will use two parts, two classes to complete this topic. So this topic is very important. After we learn this topic, I will give you project 2 on this topic. So we need to do another project, programming project on this topic. All right, so let's start. Before I talk about this topic, I want to make some comments on several questions in the midterm test. The overall result pretty good. So you got an average 77 average points, but still there are several questions. I need to make some comments, so quickly go through those questions. The first question, question number 2. So this one, most of you got this one. I lost my statistics. I tried to save to a file, but after I open it, I couldn't see the the statistics I did on it. So next time I will do in a different way. All right. So here I just do based on my impression. A few students missed this one. We practiced this many times. But some students, so if you did not follow closely, especially we have several videos talking about this topic. If you didn't follow those videos, if you only try to find the answer based on your intuition, it is very likely you will miss the answer. Why? Because based on intuition, the first question, it looks like a very big function, right? Increases very fast, very big function. The second function, 1.00, so many zeros. Then exponent n. But your intuition may not tell you for a long run how to compare these two functions. Your intuition is not reliable enough for this particular question. Because based on what the theory we learned, this how high the power is, it is a polynomial. That one, so even so many zeros after 1 point, decimal point, still it is an exponential function. A to the nth with a greater than 1. Okay? A greater than 1. So this exponential function and polynomial, we know any polynomial, any number k, but it is fixed. It is not a variable. It is of little o exponential function. So we learned this. We show using the limit n goes to infinity, n to the k over a to the nth equals 0. Okay? We can use L'Hopital's rule to prove it. So you can see if you follow our notes, videos, homework questions, practice exercise questions, all the way down to this point, you won't miss it. We practice so many times, at least 5 times on this particular question. Based on my impression, 3, around 3, that number. It's a not big number, but there are several there missed this question. Okay, all right. So that's the question number 2. Next one, number 4. This one, yeah, a few more students missed this question. Yeah. Several students, yeah, I estimate 4 or 5 students, gave me C answer. It's not. Correct answer is D. Yeah. Why C is not? First, n factorial. Yeah. It's good. Those students, they didn't choose A and B. Yeah. So they know a little bit. So they didn't choose A and B. That's good. But something that is not very good, they choose C. They're not familiar with n factorial. Now, n factorial, you need to go back to the, what's that? Stirling formula. Stirling's formula. You need to know that. Okay? If you know that, approximately n to the nth over e to the nth. Okay? Yeah. So if you want to try to imagine how large is this function, approximately, you can use this exponential function, you know, to estimate that. Okay? Yeah. If you use this one, then you can get answer easily. Yeah. All right. Smooth function. Now I hope we practiced several times, so I hope you know how to see it. Yeah. We want to know smooth function, the critical condition it must satisfy. F of 2n belongs to big O of big theta big O of f of n. Okay? Yeah. And this one you can see that easily. Okay? Yeah. F of 2n for this case 2 to the 100 times n to the 100. Okay? Can we treat this as a constant? It's a big number, but we can treat it as a constant. Yeah. Because when your n changes, your n is variable. When your n changes, that constant never changes. This constant never changes. Okay? Yeah. So it's still big O of n to the 100. Okay? Yeah. So it satisfies this smoothness condition. Okay? Yeah. So that's question number 4. Now, the next question. Number 8. Yeah. Number 7. Yeah. We did unordered array. Number 7 with 12 elements. We need to find the maximum number of inversions. That one, most of you got it. Yeah. I didn't see anyone miss that question. So I didn't talk about that here. Yeah. Almost, yeah. So I lost the statistics. Yeah. Otherwise, I can show you my statistics. Yeah. All right. But this one, quite some number of you missed this one. Okay. Yeah, most students gave me 10. Yeah, that is the, the question that appears most number of times. Why 10? I think those students, they connect to another phenomenon. Yeah. So they connect this question to another phenomenon. So what's that? Okay. This question, best case, worst case, efficiency. Yeah. Because the worst case, so they use that 1 plus 2 plus, the previous question, 11, right? Yeah, so that's the answer, 66. Yeah. Then, based on their experience, because this one, it is pretty close to that worst case formula, right? Worst case formula. Yeah, worst case formula, usually we have that expression. So those students connect to that formula automatically. Then the minimum, so they connect to the best case formula. Right? Yeah, sorry, best case formula. Yeah, best case formula, most of the time that's n, right? The best case, 1 plus 1, 10 times, yeah. So that they give that 10, but here it's not. The concept is different. Here we are talking about inversion, right? What's the inversion? So you know the meaning of inversion, right? Yeah. So the answer is 1. You need to, when you understand this concept, you can easily get that special situation. Unordered, you only change the order at one place. Okay? For example, yeah, I saw some students list those numbers. It's correct. Yeah, perfect. So here, if you ask me to list that special case, I can list this way: 2, 1. Okay? Only the first 2 elements I switch the order, so I can make it inverse. So here you see 1 inverse, right? Yeah. After that, then I will use the natural order all the way through 10. Okay? After that, you can see you won't find any other inverse. There is no second inverse anywhere in this array. Okay? So then your answer is 1. That's simple. Okay? Yeah. So all rely on understanding here. Yeah. So when you understand this concept, so you just try to imagine the situation, the array, how do you make one special example, so that gives you the minimum number of inversion. Yeah. So that's this question, number 8. Yeah. Next one, number 14. Yeah. Number 14, many of you did quite well, yeah, but I estimate approximately 1/3 of you didn't do quite well. Yeah. Some students couldn't figure out how to do it. Yeah. Some students only missed 1 sign, yeah, only 1 place. Yeah. Plus minus, only 1 place. Yeah. Here, so let me show you. Yeah. All right. You have many ways to, usually for a question like this, the solution could be several different ways. Yeah. Whatever the way it is, just find the correct solution. Okay. Yeah. This one. All right. Some students use that formula. Yeah, that's okay. Yeah. I like to use that. Yeah. Some students, phi cube plus 1, there is a 1 formula like this. Okay. Phi square minus phi plus 1. Yeah. Several students use this formula. Yeah. Some students may not know this formula, but you can still do it, right? So if you do not know this formula, you can do in this way. Phi times phi square, right? But for Fibonacci number, you can replace phi square by phi plus 1, right? So remember, so we have that formula. Yeah. Phi square equals phi plus 1. Okay? Yeah. So you can use that way. Yeah. All right. So here, we use this formula, phi plus 1, but this time, phi square, we know, equals phi plus 1 minus phi plus 1, right? Yeah. So replace phi square by phi plus 1. Yeah. In this way, cancellation, right? Yeah. 1 plus 1, 2. So 2 left. You have 2. Denominator, numerator, can you cross out? 1 over phi plus 1, right? Yeah. Okay. 1 over phi plus 1. Yeah. Phi plus 1, phi plus 1. Can you use 1 over phi square? Right? Yeah. We can use 1 over phi square, right? Then 1, replace 1 by phi square minus phi. Can you do that? Yep. We did. several times. We replace 1 by phi squared minus phi over phi squared. Okay? Simplify it 1 minus 1 over phi. Okay? All right, the last step. Now, we already have integer here. Okay? 1 integer here. Last step, 1 minus that 1. Use this expression another time. Phi squared minus phi over phi. Okay? Yeah. Cancellation, numerator denominator cancellation, 1 minus phi minus 1. Parenthesis. Don't forget those parentheses. Some students forgot to put that parenthesis. Then the last step, so they lost 1 point. Yeah. Several, I noticed. 3 or 4 students just missed one place, one sign. Yeah. Otherwise, all correct. So the answer 2 minus phi. The answer. Yeah. So when you do calculation, do it carefully, step by step. Yeah. Don't miss any parentheses. Parentheses very important. Yeah. And use this formula several times. You need to identify under certain situation which version of the formula should be used. Yeah. All right, so that's question number 14. The next one, yeah, this one, this is a big miss. Yeah, more than 50%, I estimate. Yeah, missed this question. Yeah. The biggest mistake. Yeah, so very strange. So many students make that mistake. They use some wrong formula. 8s plus 3. Those students write this way, plus 3. They take that 3 out of the log. We cannot do that. Okay? We cannot. It is wrong. It is very wrong. Yeah. Don't do that. Yeah. You cannot do that. Yeah. The only way you do the simplification, use this formula. Using that formula. Yeah. We did several practice questions. Several places. Yeah. But still, this is a very weak point of many of you. Yeah. Here, let me quickly do that. All right. So we want to simplify the expression of this one. Okay. All right. So now, here, look at the floor function, right? Floor function. Floor function, it corresponds to that part, that term. Okay. So that term, we can use ceiling function now. This part minus 1, right? Yeah, 1 we can do subtraction. Yeah, so we will have log base 2 of this whole thing. Yeah, because that s here, that whole thing, 2s plus 3 plus 1. Here we need to add 1. So we get 4. Okay, all right. Minus 1. How about that? Yeah. The good thing of this expression, you have a common factor 4. Yeah. So that's something we really needed. Yeah. This time we take that 4 out. 2s plus 1 minus 1. Okay? Yeah. Then we can use some property of log of product of 2 positive numbers. Yeah. So then we can have 4, this addition here, 2s plus 1 minus 1. Okay, yeah. This is 2, right? 2. 2 inside the ceiling function, it's an integer. We can take it out and combine with that -1. So after we simplify it, we will get 2s plus 1 plus 1, right? Because plus 2 minus 1 plus 1. All right. So then use this formula another time, another time. Ceiling function here. So can we have log base 2 floor function 2s, 1 is gone, right? 1 is gone. Plus 1 plus 1, right? Yep. So 1 from this formula, 1 from the previous term. Yeah. So 2 here, right? Yeah. But 2 times s, you have another 1 out, right? Yeah. So this you have another 1, 2 plus 2, right? Yeah. That is 1. Integer, you can take it out of the floor function. Combine with 2, you get 3. Okay? So you get s floor function plus 3. Yeah. Using our notation, 8 plus 3. See? That's how you get there. You can see you need to use several times this formula. And also some properties of logarithm and the properties of floor function and the ceiling function. So that's all you need to solve this question. Okay, yeah. All right, number 15. Next one, number 19. This question, yeah, the answer is 5. Yeah. It is not too hard. Yeah. We work on this kind of question also several times, similar questions several times. Yeah. Yeah, but still, many students missed this question. Okay? Yeah. The problem is this. Yeah. First, let me talk about the solution. Then, I point out one special problem. Yeah. First, we know the first 3 elements are already sorted. The last 2 not sorted. To make the whole array sorted, we just do insertion. Okay? Insert x4, then x5 twice. When we insert x4, compare x2. Binary search type insertion. Then the remaining, any case, just one more comparison. So when you insert x4, you need 2 comparisons. But after that, you get a ordered array. The 4 can be anywhere, yeah, but here it's not important because you have a ordered array with 4 elements. Now you insert x5. This time, the worst case, you need 3. The worst case. Okay. Not best case. Okay. Best case 2. The worst case, 3 comparisons. Yeah. All right. Yeah. 3 comparisons. 2 plus 3, 5. Yeah. So that's the way how we get a solution. Yeah. All right. But there is one. A few students give another solution. The way understanding is slightly short of the correct solution. Yeah. So those students, so that's what I like to explain here. Yeah. But the problem is a little deep. Yeah. So those students may not be figure out the reason behind it. So I want to explain here. All right. So those students explain in this way. Yeah. First, they use the background. the best algorithm, we can sort 5-element array using 7 comparisons. Okay, yeah, so that's true. The best algorithm, okay, yeah, 7 comparisons. Now they claim in this way. Yeah, I used this explanation once before. Yeah, but when we use this way, we should be very careful. All right, so 1. Yeah. Now we have this one, right? And that student argue because we need to use 3 comparisons to get this, right? So 7 comparisons, 3 out of 7 used to get this one, but we already have this information, so we don't need that 3 comparisons. The remaining, so what do we need? Just the 4 comparisons. Yeah. But that argument missed one very subtle point. Yeah, that point is very subtle. Yeah. Usually people cannot see it. Yeah. That subtle point is, all right, here, let me give it to you. When we use 3 comparisons, we can get a more than that, more than sorting this plus, okay, plus some more information. Not just that, plus a little more, okay? So what do we get? So look at this. x1, x2, x3, x4. One comparison assume x1 less than x2, x3 less than x4. Okay? Another comparison x1 less than x3. So that's 3 comparisons, right? 1, 2, 3. After that, what do you get after 3 comparisons? You get x1 less than x3 less than x4, right? But you also have x1 less than x2, right? Yeah. So that means you get more information than an ordered 3-element array, just like that, because you have this another important piece of information. You have it. This is useful to help you use fewer number of comparisons. Now, so that's the reason you cannot use fewer than 5 comparisons to sort it. Okay, so you need yeah, right. You cannot use 4, so you need to use 5. Okay, yeah. But there could be a challenging question. Yeah, yeah. Is it possible using 4 comparisons to, to sort with this condition? Yeah. I didn't try it. Okay, I didn't try it. I can only say it is possible. Yeah, if any of you can do that, that's very interesting. Okay, so then I will give you points back on this one. Okay, all right. Then the last question I want to talk about. Oh, not last. Yeah, 2 more questions. But this question, there is one common error, very common. So many of you missed sign here using minus. Okay, then they put a minus here. Yeah, so then they get root 6. So many. So I couldn't understand why the sign, you use a different sign there. Yeah, I couldn't understand. Yeah, so think about, so why you missed that. Yeah, other than that, everything else is normal. Okay, yeah, but some students, give me, some very strange expression, yeah, also several, with that, yeah. Yeah. Anyway, yeah. Last question. This one. This one is not very hard. Yeah. So I do not want to give you very hard question. So this one, I think it's doable. For most of it is doable. Yeah. But the result, the most commonly missed part of this question, so many students missed B2. Yeah. Many students give me A1 and a B3, but forgot B2. Yeah. So those students give me A1, B3, but not miss that B2. Yeah. All right. So here, let me explain the way we solve this one using the elimination method. Elimination method. In our class, I emphasize many times. It is very important in problem solving. You use this special view, sometimes you can get really good result. Yeah. So I want to do some testing on this topic, elimination topic. All right. Here we have total 6 elements. 1, 2, 3, 4, 5, 6. Yeah. We imagine the whole array is sorted with 6 elements. Then the median, because we consider the median, this is the median. Based on our definition, this is the median. Okay? If you look at from the left-hand side, it is the third from the left-hand side. From smaller side, if you look at from the larger side, this direction, you will see it is the fourth. All right. Based on this observation, you can do the elimination. Yeah. All right. So first, why A1 can be eliminated? Yeah. Because A1, if we look at from the larger side, it cannot be the fourth. From the larger side, we can see A1 less than A2, less than A3, right? Yeah. Also less than B2 and a B3. The reason less than B2, because we have this inequality. A2 less than B2, okay? So B2 greater than A2, A2 greater than A1, so that's why B2 also greater than A1. Yeah. So you can see this observation, you can eliminate A1. Yeah. Then B2, B3. Yeah. B2, you look at from left-hand side. Left. Okay? Yeah. So for B2, A1 less than B2, right? A2 less than B2, right? B1 less than B2, right? Yeah. Less than B2 and B3, right? Yeah, both B2 and B3. Okay? So from the left-hand side, they cannot be the third one, right? Yeah. Because 1, 2, 3, how can you get into the first 3? You cannot get into it. Okay? You do not have chance to get into the first 3. Yeah. So the answer A1, B2, B3. Yeah. So that's this question, the solution of this question. Not very long, yeah, just a few lines, yeah. But you need this special view to find the solution. Yeah. All right. So that's this midterm test. So we put this behind. I will post the answers. So if you like, you can study. But from now on, we need to prepare for the final. Yeah. All right. So let me stop here. Yeah.